Relations depending, because look at it's logical. Do you agree with me that the viscosity is going to be higher when the molecule is very long? Are we together? So just imagine if you send outside, they give you results, it's just opposite. So people should not fool you, especially working with the green tea. So this is one of the formula used, but there are other formula that's going to help you to determine all those properties. In summary, guys, we succeeded last year to prepare our biodiesel, and we optimized the operating condition in such a way that the molar ratio between the oil and the alcohol is supposed to be 1:25. The temperature is supposed to be 70 degrees. The catalyst loading 70%, and the reaction time is supposed to be 3 hours. And all the properties have been tested, and they were falling within the standards as set internationally. So, in conclusion, the aim of the project was achieved, and the optimal conditions were attained, as I've shown to you just in the previous slide. And the catalyst was tested, and it's proved to be really active and also stable for the trans-esterification process. And the catalyst also could be used before and after making the biodiesel. And as a recommendation, we suggest that the project might be continued, and this is basically what our friends are currently doing. And the catalyst is supposed to be reused many times as possible. And also, the samples of your catalyst, we are sending them now to the UCT and Stellenbosch so that they may do the XRD and the CEM to know the size of your particles, and also the PET to know the surface area of the catalyst, because do not forget the activity of your catalyst depends on the surface area. Bigger is the surface area, more active going to be the catalyst. But do not forget, if also your catalyst is so small, it's going to be difficult for you to separate it from the solution. So you have to balance, okay, both parameters. And finally, you will have to design and to construct a pilot plant at your level that should be able to produce 250 liters per day. I would like just to show you the picture that we are expecting to get from you guys. So basically, because of your reports, your P2 reports, you should be able to develop a process flow diagram that looks like this one, where you need to tell us what should be the size of this reactor and what should be the diameter, that's the inner diameter, and you need to suggest to us what kind of heating process, because when you will check the efficiency using the heating bath now, the efficiency can be 5% in terms of energy. Are we together? Is it good? 5%. Why the efficiency should be more or less 5%? Open, due to what? Heat losses, due to what? Convection? And radiation. Because it's open, so most of heat's going there. And this is unacceptable for engineers. Takunda is partner of engineers, okay? Is unacceptable. For the lab, yes, you can impress people. Yes, we got the biodiesel. Yes, the biodiesel working. We're gonna check it even in the car. Are you with me? But if you are dealing with a fine chemical engineer, he will just tell you what is the efficiency using that apparatus. Then you have to develop, it should look like that one. Where the heating element, that's why the practical that we did with some of our colleagues, we said if you do have a heating element inside and outside, which one is going to be more efficient? you have to think about it. Okay, guys? And this is going to be your main job for these projects. Because up to now, what you've done, it's nothing. Is it okay? You have to, don't look at me like this, Congolo. You have to come up with a proper reactor. With the little money we do have, we're going to design it, and we have to get to 250 liters per day. The HOD is supposed to have 40 liters of diesel. And even Mr. Mpela, because his car he drives with diesel. 40 liters you give to him.
Increase the salary.
Increase the salary. Good. Okay. So basically, these are the kind of equipment you're supposed to come up for your final stage for your report, guys. Once you develop a pilot plant like this, we can close the project. That's it. Any question? Any question?
25 to 1 ethanol per palm oil.
Yes.
Mole-wise, I don't know. Or
Molar ratio.
Yes.
Mm-hmm.
And I researched on Brazil, you said. Brazil, they are currently using pure ethanol as fuel immediately. Why would you need such a huge amount of ethanol to make biodiesel instead of using it directly into your car or any other thing?
Okay. Can somebody answer to the question? Why do you need a huge amount of ethanol to make your fuel, your biodiesel, instead of using 100% ethanol? You just have your ethanol and you fill it in your car and your car start driving. Or your car start running. Engineers?
Some of them
I
are.
think we all know that 100% efficiency is what we call utopia. It's not really possible to have 100% efficiency. The maximum you can do is 88%. There are still impurities in your product. That's the reason why it's advisable, or it's much more efficient to go for a process which is a bit less efficient than targeting the 100% efficiency.
So, you mean to reach 100% purity of ethanol is quite difficult than for biodiesel.
Yes, Takunda?
So he asked, why won't we use ethanol directly? Okay, I would like to highlight the energy per mole which is used, because when you form an ester, it's a stronger bond, and to break that bond, it's going to release more energy, to say, than ethanol alone. So that's why we have to come up with a balance in the enthalpy change of the energy which is going to be used. I think that would be the main reason.
I like this. Look at it. It's very simple. In chemical engineering, okay, that's why you see students used to find me very rude. They know me. I'm strict. We don't play with chemical. When it comes to chemical engineering technology, there is no game. Either you know or not. When we saw the concept of energy. We spoken about the higher heating value of substances. Because when you burn your hydrocarbon, your fuel, it's supposed to release energy, as he said. If you do have just two carbon, you break just one bond. Then when you do have 15, how much energy will be released when you have 15 atoms than having only 2? Apparently, okay? It seems like, yes, we can use just 100% ethanol. But is it going to release more energy than for one molecule of an ester which is very long. So you have to look at the heating value. You saw among all the parameters, we talked about the certain number and the heating value. What is obvious, the heating value of a biodiesel is higher than the heating value of ethanol. It means that you're supposed to have, as you said in Swahili, someone can have just 1 liter of biodiesel, but you're supposed to have a ntuku of ethanol to run. Okay? Some other stuff you're gonna just cut.
They are good. They are good.